Everyone. This is our first session on Module 8 Shear Walls from Building Structures 6. In today's session, we are going to learn about Introduction to Shear Walls, advantages and disadvantages of a shear wall, construction, materials used for shear wall, applications of shear wall, or where the shear walls are used. So let us start with the definition of a shear wall. A shear wall is a vertical element of seismic force resisting system that is designed to resist in plane lateral forces, typically wind and seismic forces. Or in simple words, I can also define shear wall as a wall in a building which resists a lateral loading originating from a wind or a earthquake. So by definition, we know that it is a vertical element as well as it is a force resisting system, one of a type of a force resisting system, because it carries or it is capable of carrying forces or loads, and those loads are nothing but in plane lateral forces. You know the definition of a lateral forces, but these shear walls are specialized in carrying in plane lateral forces. We will see what exactly the in plane lateral forces are. Now, why these shear walls are important because shear walls have a very large in plane stiffness and therefore resist lateral loads. They have a large in plane stiffness. Then another thing is shear wall can control deflections very efficiently. These walls can control interstory deflections caused by a lateral loading, especially in high-rise structures. These can also provide a protection against a costly non-structural damage during a moderate seismic disturbances. So these are the important points regarding shear walls. To explain these important points, I would like you to consider this building. So this is a tall structure, any kind of a tall structure, and there is a lateral load or a horizontal load which is applied on the tall structure. As soon as the load is applied, a building starts to deflect in a opposite direction of the load. So when this building deflects, what happens is there will be a number of stresses, strains, deflections which are caused in the building of the structural material. So if a building is deflecting in this direction, then this face of the building will be under compression, whereas this face of the building will be under tension. You can see the length is slightly increasing on this side because the building material is getting stretched, whereas it is getting compressed on this portion. So whenever lateral load is applied, a building deflects in this particular manner. So when this type of deflections are caused, there will be a change in the angle between a beam and a column. Say suppose this is a column, this is a beam. There will be certain difference between the beam and a column. If a building is flexible enough to take such differences or to resist such differences, then the building will be safer. But all materials will not be that much flexible. For example, if I provide a window here in this portion, if I provide a window, then when a building deflects, it may happen that window frame may get deflected or may get distorted. So because of that, the glass window may broken up and non-structural damage can also be happened. So shear walls can provide a protection by reducing the deflections, hence a costly non-structural damage can be reduced. Next is shear walls control the interstory deflections caused by a lateral loading, especially in high-rise structures. So if I provide a shear wall which is acting against a lateral loading. So lateral loads are drastically reduced because the diaphragm will provide the opposite interacting forces or resistance, and the lateral load, the force is applied on the shear wall, will be considerably reduced, and hence deflections will get reduced. Because of reduced deflections, the interstory drifts are also getting reduced. So for example, for understanding this, I'll be explaining the concept of shear wall with this diagram. Here we have a shear wall, which is a vertical wall, and we have a floor or a slab, so which we refer as a diaphragm. Diaphragms are the rigid floors or slabs assemblies capable of transferring lateral forces to a vertical resisting element. So whenever a lateral load is applied on a building, say suppose this is a building, then a lateral load is applied in this direction. So when lateral loads are applied in this direction, since the slab is rigid type, means stable type, so what happens is this slab will deflect in this curvature, along this curvature. So when this deflect along this curvature, the inner side will be a compression side, whereas the outer side will be a tension side. Now this diaphragm is rigidly connected with the vertical structural member, which is nothing but a shear wall. So because of this, what happens is the applied load is in this direction, the forces for a tangential, the shear force for a tangential diaphragm will be induced in the shear wall. So to counteract this, which is interconnected with the diaphragm by Newton's third law, there will be a resisting force which is equal in and opposite in direction to this applied load as a shear force. To resist that, there will be equal and opposite force which is acting in the on the edge of the diaphragm. So if the lateral load is acting in this direction, the resisting forces will be acting in the opposite direction along both the edges of the diaphragm, and the diaphragm will be under a compression in this phase, whereas it will be under tension along this phase. Now come to shear wall. As by the definition, we have seen that these are the vertical structural members which carry the lateral load in plane direction or along the plane of the wall. So if you consider this axis system, say this is a x-axis, this along this line it is x-axis, along this line it is z-axis, and vertical it is y-axis. Now shear plane is along x, y plane. Shear wall is along x-axis and along y-axis. So I can say that shear wall is in a xy plane. So in plane forces are nothing but when the forces applied on a member are along the same plane as that of the member is. So here the shear wall is in xy plane, whereas the lateral load applied is also in xy plane. It is acting along the plane of the member. So this type of forces are called as in plane forces, and shear walls are capable to carry in plane lateral forces. Means if I apply a lateral force along this line, this member will definitely it will deflect, but to a very less extent as compared to a normal wall. But what happens when I apply a load or a lateral force along other plane, means out of a plane of a shear wall? Say I will apply lateral force along ZZ axis, along this line. So if that happens, then definitely this wall will deflect more, or it may fail also. So as per the definition, shear walls are the vertical elements of a structure which carry a in plane lateral forces. Why this happens is because along this plane, along xy plane, stiffness of the wall is comparatively more than along xz plane. So when I apply a load along this, there will be a very huge moment of inertia as well as a radii of a gyration, but whereas when I apply the load along the z direction, moment of inertia will also be less and radii of gyration will also be lesser. So these are just like structural members which will deflect very less in this direction, but it will deflect very huge in this direction, along this direction. But when I apply a load in this way, the deflection will be comparatively very less. So because of this applied load, there will be these walls are very rigidly connected to the foundation. So when I apply a lateral load which are going from right to leftwards, there will be a resisting force at the base of the wall which will be acting from left to rightwards. Not only that, when I apply a load in this direction, what happens is this side is under compression and this side is under tension. So this wall will be deflecting like this. So because of this deflection, there will be a chance that this end of the wall may get lifted up, whereas this end of the wall may get squeezed down. So because of this, to make sure that lifting up is not happening, what we do is we anchor down, or we held down the wall so that it can stick to the foundation very firmly. We call them as a tie down or a hold down forces. So this force will try to resist the uplift, or will try to avoid the uplift of the wall by acting in a downward direction. Whereas on the other side of the wall, there will be a compressive force which will try to squeeze the shear wall. So these are the forces which are acting on a shear wall. Apart from this, there will be a gravitational load of the shear wall which is acting in a vertical downward direction. So shear walls are not only the walls which carry lateral loads, but these walls will also carry the gravitational loads, but much importance is given for a lateral load, since these are the major parts of a lateral load resisting systems. So what are let us see different materials which are used for shear walls. Shear walls can be constructed of structural steel, reinforced concrete shear wall, masonry shear wall, or a wooden shear wall. If it is a structural reinforced concrete shear wall, there will be a reinforcement along the plane of the shear wall along x direction as well as along y direction. The reinforcement may be either in a single layer or it may be in a double layer. Whereas at the end of the shear wall, there will be a bunch of reinforcement or a number of bars which are provided, so that tying of a reinforcement is intact, as well as the joints of a shear walls are much more stronger. If it is a masonry shear wall, there will be a brick masonry layers, and in between the masonry layers there will be a reinforcement provided. Usually for this type, hollow bricks are used along the hollow sections of the brick reinforcements are inserted inside the masonry wall. If it is a wooden shear wall, there will be a frame, then the strengthening stiffeners. So these stiffeners are anchored, bolted or held down at the bottom so that a shear wall is not lifted up. Then the shear wall is covered with a structural wooden panel, and these panels are nailed by providing a nails to the intermediate stiffeners. So this will be how wooden shear walls are look like. But most of the times we prefer a reinforced concrete shear wall or a structural steel shear wall. Masonry shear walls and wooden shear walls are very rare in use. Now let us start with advantages of what are the advantages of shear walls. These are the thin sections as compared to a normal wall. These are lightweight since these are thinner sections, so self weight of the walls are drastically reduced. These will reduce a construction time because for constructing shear wall we just provide a reinforcement cage and we pour a concrete and shear wall will be ready. Increased performance, as you have observed in the previous explanation, that it will reduce deflections, lateral deflections or a story drift, as well as it provides a safety against lateral loads more efficiently. Then well distributed reinforcement, hence these are cost effective. If a shear walls are when these are not as cost effective as a normal masonry wall, but when you compare the capacity of a structure with its cost, these are comparatively better. These minimize the structural and non-structural damage to the structural and non-structural elements and provide a large strength and a stiffness in the direction of orientation. Now the disadvantages of shear walls are these are difficult to construct because the most important thing is designing of a shear wall, which is quite complicated compared to a normal wall, and also reinforcement has to be precised and construction should be supervised. Next one is these require large moment connections. Wherever shear walls are connected to other lateral load resisting systems or other load resisting structural system, a moment connections has to be provided because these walls carry only the lateral loads, but when the lateral loads are applied in the out of plane area, they may fail to carry such loads. So to resist such loads, moment connections are provided. Then these are of quite flimsy in appearance. Next one is why or where we apply a shear walls or where we require a shear walls or why we require a shear walls. Shear walls are designed to resist gravity loads as well as lateral loads, especially lateral loads. So wherever the lateral loads are comparatively higher, we provide a shear walls. These walls are structurally combined with the roof or the floors. So by interconnecting slab or a diaphragm with a shear wall, we can increase the strength and the stiffness of the structure, as well as it will form a structure as a single rigid act as a single unit. These walls have to resist uplift forces due to the air drag. Because of wind forces, there might be some uplift forces which may cause failure of a structure by uplifting, and these walls must resist such forces. The supporting area is comparatively higher as compared to RCC framed structures. So if shear walls are provided, below the shear walls there need to be a firm foundations, hence a supporting area will be comparatively larger. These walls resist the lateral forces of air that push the wall in and out of the structures. So this is as per the definition. Thank you for today's session. We'll continue in the next session.